All right, for our next example, we're going to write another assembly program, but this time we're not going to have a step where we explicitly write the working C version. We're going to try to go just using the design recipe for assembly in order. So the program that we want to do is that it's going to take a string as the first user argument. We're going to determine if all the characters in that string are the character number 5. If they're all 5s, we're going to print out all 5s. Not all 5s, we're going to print not all 5s. So examples, if we do 5s and then have some 5s, that's going to print out all 5s. If we say something else, it'll say not all 5s. And then if we have something that's like 5A, 5, 5, 5, 5, that's also not all 5s. Nice simple program, but it has some useful stuff in here. To do this, we're going to start our program with the main function, because that's the place we clearly want to start. Although there is one thing that we can write before that. We can write our data section, and we can have a all 5 string, and we can have a not all 5s string, because we know we're going to need those things before we even get into writing any stuff from the problem description. But then we're going to do our main function. So first step of main is signature. So int main, int argc, char argv, array. Our pseudocode is going to be something like if all 5s argv1 in fact, let's be more generic. Let's say all match argv1 and then pass it a character 5. If they all match, we're going to put all 5s, else we're going to put not all 5s, then we always return 0. So there's our pseudocode. Now we can do our variable mapping. Immediately looking at this, there aren't any named variables. So we're going to leave our variable mapping kind of empty. So that was signature, pseudocode, mapping. And we might discover that it can't be empty. We may need to put values in registers, but we'll see what happens. Skeleton, main, enter 0, 0, leave, right. After skeleton, we can do function body. So the first thing that we want to do here is we have this if then else. So that's going to be a condition. We're going to have then and else branches. We're going to have a done branch. We always return 0, so we can move 0 to RAX. The condition is going to be the result of calling this all match function. So we'll mov 8 RSI to our DI. And then we need to move a char to our second argument register. So we can do a char literal by saying $single quote and then the char we want to do. And since we're moving a char, which is represented in C as a 8-bit integer, rather than using the RSI register, we're going to use the SIB register. So that's I think that's what it's called, SIB. It will find out if it assembles. If it doesn't assemble, I'll have to go look it up. But we want the 8-bit version of the SI register. I don't know. We'll find out. Then we call all match, and then it's going to return its result in RAX. So we can do a compare of 0 with RAX. So this if is going to all match is going to return a C Boolean. C doesn't actually have a Boolean type, at least not historically. Instead, it's going to use an integer, probably a 32-bit integer, but for our purposes, it's going to return a 64-bit integer where 0 is false and any other value is true. So if it is not equal to 0, then we go to main then. Otherwise, we're going to go to main else. In the then case, we move all 5s to RDI and call puts. Otherwise, we're going to move not all 5s. And we're going to optimize this because I want to. Even though we don't have to optimize, we only need to call puts once. And so there's our main function. So that's fine and all, but in the process of writing the main function, we sort of delegated all the actual hard work to this helper function all match. So let's go ahead and design that one. So all match is going to be int, because that's how we spell Boolean in traditional C. All match, and then it's going to take a char pointer. That's how we pass a string. And it's going to take a char. Let's give those names, text and cc. The body of the function is going to be for long II0. We can do better than that. We don't actually have to do the size. So the way strings work is the char pointer is a memory address that's going to point to the address of the first character in the string. And then we don't know the length of that. It's just pointing to the first character. So the way we tell that the string is done is that all strings are terminated in C, or assembly as we're writing it, with a null byte. So we can actually say for, we can even say while text. That's going to, if the current character we're looking at is not the end of the string, it will be true, otherwise it will be false. We'll then do text ++ to go to the next character. And then if the value at text is does not equal cc, we'll return 0 because we found a character that didn't match. If we look at all the characters and they match, we return 1. To be clear, the other version of this that I was thinking of was for int II0, II is greater than strlen of text, ++II, if text II is cc, or sorry, does not equal cc, we return 0. Otherwise, we return 1. So these two pseudocodes are actually completely equivalent. They might, in a reasonable C compiler, both compile to the same assembly code. So we're going to have to write some version of the function that is going to work. They actually can't compile to exactly the same assembly code because this is doing a strlen and has an II variable. So I'm wrong. They compiled a different assembly code. They do the same thing. I want to implement the top one because it doesn't have the function call, which means we don't have to worry about safe registers. So that's our pseudocode. Now we need our variable mapping. We have no function calls, so that means this is a leaf function. We don't have to worry about safe registers. So our variables are text is RDI, CC is RSI, and that's it. Those are all the variables. So all matches enter 0, 0. We don't have any non-temporary registers, nothing allocated on the stack, so we can just go ahead and enter 0, leave ret. So now we have this while loop. So our condition is, first thing on the while loop is we need to actually have a thing. So all matches condition. We need a label for the top of the loop. Now we need one for it being done. But that's actually different from the function being done, because we want to be able to return in two different cases. We want to be able to return from the middle of the loop. We want to be able to return from the end of the loop. But we don't want to have two ret instructions in the assembly code, because we want to make sure that if we have any cleanup in the prologue to do, we only have one path to exit the function. We don't want to have to remember whatever cleanup we're doing and make sure that it stays consistent in two places. We want one return point for our function. So our condition is the question, does the let's get this right. We need to dereference it because this is a memory address, but we're interested in the value in memory at that address. So both of these should be dereferenced. And this makes me want to optimize a little bit more. Let's go ahead and say char XX is the char at the text. This isn't really relevant to the C version, but it means that we get to name another variable. And so we're going to make XX be R10. So we're going to compare R10 with 0, except XX is a char. So we don't want R10, we want R10B, which is the 1 byte version of that. And we don't want RSI here, we want SIB, which should be the 1 byte version of that. Still not sure if that's right. We'll find out in a little while. So we're going to compare 0 to R10B. If it is equal to 0, we're done with the loop. Now this is text is an array of char. So here we want to increment that. We can just go ahead and increment RDI, bottom of the loop, and then we're doing our if condition. So compare SIB to R10B. If they are equal, we're going to do the next iteration of the loop. Otherwise, we're going to mov 0 to RAX, and then we're going to return that 0. And we're going to do that by jumping to all matches done. If we end up getting through the loop here, we are going to mov 1 to RAX, and then we'll also return there. The one thing that we need to do first before we do this comparison is we need to actually load that. We can't actually have this outside the loop because that's going to do the wrong thing. We really do want this text so that we do a load every time. So we want this to be the value at text. We're going to assign a register to that value. So we're going to move the value at text, which was RDI, to R10B, which is fine. In the C code, we're doing 2 loads. In the assembly, we only have to load once. That's a reasonable optimization. Let's see if this assembles. Bad register name SIB. Cool. Let's look it up. So we go to ntuck.neu.site. Then we're going to go to 3650. Then we're going to go to the cheat sheet. We discover that RSI is called SIL for the low things to be consistent with AL. That makes sense. So every time I typed SIB, what I meant was SIL. That's both in the all matches function and in the main function. So we have SIL here. So we go ahead and assemble that. Undefined reference to all match. So we called something called all match. Now it assembles, we say 5s, now we crash, that's fine. That's just us not handling our argument. So if we say boat, that's not all 5s. If we say 5, 5, 5, 5, 5, that is all 5s. And 5, 5, 5, x 5, 5 is not all 5s. Our program works, and that demonstrates the design recipe again. And it also points out how to deal with this question of how do we load individual characters from a string into a register, which is important.